Hello all. So here we are doing worksheets on simulation and prediction. So in order to obtain the probability of various events, a simulation is often conducted. It allows us to represent the likelihood of a real life event occurring by using an experiment with similar predict possibilities. Sometimes we're not able to calculate a theoretical probabilities because there's nothing to base our theory on. So we have to conduct an experiment, and then we'll use the results of the experiment to predict what's going to happen in the future. So this method is used by researchers when it is difficult to collect experimental data or when the theoretical probability is unknown. So let's say you decided that you wanted to make orange juice and sell your orange juice at farmers markets. Before you go ahead and decide to sell it, you would like to know about how many containers do you think you'll be able to sell each week to see if it's worthwhile to do this. So maybe you go into a classroom of 30 and you give each student a taste and say, okay, is this a product that you would buy after tasting it or not buy? And let's just say that 12 out of the 30 decide that they really like this and that they will buy it. So that was our experiment, and that's going to be how we're going to predict what will happen when we actually go to the farmer's market. So let's go ahead, simplify this. I see these are both even numbers, so I'll cut them in half. And I see I'm not done simplifying yet. Both of these are divisible by 3. So this is 2 and this will be 5, and that's as far as we can go. So in simplest form, that's 2/5. Now, when I go to the farmer's market, I think that there will be about 1,000 people that stop by and try my orange juice and will either buy it or pass. I'm going to predict that 2/5 of my 1,000 people who stop by are going to buy the product based on the example that I did in class. Now, there are 3 different ways you can do this. So I want to show you all 3 ways, and then from here going on, I tend to like the first method, and that's the one I'm going to use, but you might identify better with the first or second method, and I want to explain all of them so you can make your own choice, okay? So the first method, I like to say if 2/5 like the orange juice, so I'm just trying to find 2/5 of 1,000, and that should give me how many people will buy the orange juice out of 1,000 people. So 2 times 1,000 is 2,000, 5 times 1 is 5, and then if I divide 2,000 by 5, that gives me 400. So I am predicting that 400 people that go to my stand are going to buy my orange juice. Now the second method you could use, you can use ratios. You can say 2/5 is going to be the same, so 2 out of 5 is the same as how many out of 1,000 people. Now let's think about this. To make an equivalent equation, don't we have to say 5 times what would give us 1,000? So I'm going to use a second variable here and say 5 times y will equal 1,000. Well, whatever I multiply the bottom of the fraction by, I must also multiply the top, or the numerator, by. So I need to figure out what y equals. So this right here gives me a nice little equation because it says 5 times a number will give me 1,000. Now, we want to isolate our variable. Since we're doing 5 times y, we're going to do the opposite and say 5 divided by 5. If I do that to one side of the equation, I have to do it to the other because division property of equality tells us we have to do it to both sides. So 5 divided by 5 leaves us with 1y, and 1,000 divided by 5 leaves us with 400. That leaves us with 200. I was a little too quick there. And now since y equals 200, I have to go back up and plug it up here. So I will substitute. So 2, take the y out, equals 200 times 200, and that will equal 400. And so x equals 400, okay? So once again, we found out that it's 400. Now, in this third method, and some of you may have seen this last year when you were doing ratios, you would start out the same. You would say 2 out of 5 equals some number out of 1,000. And your teachers may have taught you cross, multiply, and divide. So what you do here is you make a cross here and you multiply these. So 1,000 times 2 is 2,000. 5 times x is 5x, and I'll make those equal to each other. So then I have 5,000 equals 2,000. Let's see how many mistakes I can make here. Sorry about this, everyone. 2,000 equals 5x. So what do? To get the x all by itself, I divide both sides by 5. And 2,000 divided by 5 is 400. So now I know x equals 400. The only reason why I don't particularly like this method is I feel like it's a trick, and students don't often know why this works. They don't relate it to one of these. So it's a method that does work and you can use it. It's just not my favorite because I'm more concerned with you understanding the logic than just knowing how to get to the answer, okay? My favorite method is this one, although I think that's equally good. But this is the one I'll be using just because that's the way my brain tends to work, okay? So going forward, that's the way I'll show it to you. So brainstorm a simulation that could represent the same probability as the following situations. So on a multiple choice question, there is a 25% chance of getting an answer correct. So I'm going to assume we have A, B, C, and D on the multiple choice test. Well, how can I simulate that if I don't want people to come in and take the test and see what the actual chances are? I could use a spinner with 4 even sections, call them A, B, C, and D, and I could spin that and each one would represent one of the number choices that you would get on a test. Okay, how about number 2? The weather report shows that there is a 50% chance of rain. Whenever I see 50%, I'm going to think flip a coin. Okay, so we can say heads, rain, tails, no rain. Okay, an average basketball player makes 66% of his free throws. 66% is a difficult one. I know that 2 over 3 is actually going to equal 66.6 repeat. And that's really as close as I'm probably going to get to 66%. So I'm going to use that model. I'm going to go ahead and multiply my numerator and my denominator both by 2. And I'm going to get 4 out of 6 with this denominator of 6. That reminds me of a die. So I'm going to roll a number cube. And since 4 out of 6 would represent the percent that he makes, I'll say the numbers 1 through 4 will represent him making his free throw, okay? And 5 and 6 would represent him not making a free throw. There's an equally likely chance that a baby is a boy or a girl. Well, I can do flip a coin, but I already did that up there. So how about another one? Let's say you can pick a card out of a full deck. Okay, let's consider it's a full deck. And we'll say that a red card will be a girl and a black card will be a boy. Okay, so that's the same thing as like flipping a coin. Mr. and Mrs. Pinkerton have 4 boys. Every time people notice this, they comment about the odds of this happening. The Pinkertons decide to set up a simulation with 10 trials to determine the probability. What simulation could be used to represent the likelihood of having a boy or girl? Let's go back to flip the coin. So flip a coin. Which outcome represents a boy? So let's say boys are tails and a girl is going to be heads. So how should the simulation be designed in order to account for 4 different children? Well, it's a simulation. Let's say we use a penny, a nickel, a dime, and a quarter, and each one of these will be a birth of another child. So I flip it, and I'll get either heads or tails, meaning either they're a boy or girl. Flip this one, and I'll have either a boy or a girl. This one, a boy or a girl, and this one also a boy or a girl. And so that would be one set of 4 children. So since they want us to simulate this 10 times, I would just do that 10 times, and I would have 10 different outcomes of how the children may have been born, and then I can flip the or do the predictions based on that. Okay. All right. So probability can be used to make predictions for, of course, that would be the future. An example that they give us is a probability of rolling a 6 on a number cube is 1/6. If the number cube is rolled 50 times, then approximately how many times will a 6 be rolled? So I'm going to go ahead and say 1/6 of 50 is going to give us what number? So I'm going to go ahead and multiply this. I like to simplify before I multiply instead of after. I notice those are both even numbers. So this will be 25, and I'll cross this one out, and that will be 3. So I just cut them in half. Those don't have a common factor, so I'll multiply and say 25 over 3. Now I can't leave it like that because that wouldn't make any sense if I answered somebody 25/3 times. So I have to actually do the division problem, which is 25 divided by 3. So let's go ahead and just say 25 divided by 3. We're not using calculators, so make sure we're going old-fashioned and practicing our skills, okay? So 3 goes into 25 8 times, so that's 24, and we have 1 left over. I prefer to do a fraction rather than a decimal just because it's quicker and easier, so we're not going to do remainders anymore. So we have a 1, so our remainder goes on the top, the numerator of our fraction, and the 3 will go on the bottom. So we have 8 and 1/3. Now that number lands between 8 and 9, and I have to decide because I'm not going to want a 1/3 for this answer. So I want it to be a whole number. So is it closer to 8 or is it closer to 9? Well, this is closer to 0 than 1. Therefore, I'm going to round down, and I'm going to say that my answer is about 8 times. Number 6. Kinsey surveyed a random group of 7th graders as to whether they preferred video games, sports, or neither. Okay, and I see that my chart, so I'm sort of looking ahead. I see that they've already done a chart for me with these terms, so I don't really need to identify them because they're down here. Use this survey results to make predictions for the entire 7th grade class with 350 students. All right, so it says, what is a reasonable prediction for the total number of 7th graders that prefer video games? So let's say total 7th graders are 350 students. Well, let's go on our experiment. And on our experiment, we know that 15, so video games. So 15, but out of how many? Remember, we have to have both a numerator and a denominator. So we're going to add all of these up. And we have 5, 6, 7, 8, 9, 10. Carry the 1, 2, 3, 4. So out of 40 students. So I'm going to say if 15 out of 40 students, or 15/40ths, preferred video games, then 15/40ths of 350 should also prefer video games. So I'm just going to go ahead and do the math. I'm going to simplify again first, otherwise I'll have very big numbers. These both end with a 0, so I know they're both divisible by a 10. So I'll cross that out and put a 4, cross this one out, make that 35. And 4 does not go into 35, so I'm going to go ahead and just multiply now. 4 times 1 is 4, and then 35 times 15. We'll just do that on the side of our paper because, again, remember, please don't get that calculator out. So 5 times 5 is 25. 5 times 3 is 15, 16, 17. Add our 0 since this is in the tens place. 1 times 5 is 5. 1 times 3 is 3. And I'll just add those both up. We have 5, 12, 3, 4, 5. So that would be 525 out of 4, over 4, or fourths. Well, again, this is a word problem. I certainly wouldn't want to give an answer like that to somebody because they wouldn't know what I was talking about. So I'm going to have to do 525 divided by 4. 4 goes into 5 one time with 1 left over. Drop down our 2. 4 goes into 12 3 times. That goes in perfectly, leaving no remainder. Drop down our 5. 4 goes into 5 one time. Subtract our 4. We have a remainder of 4. Now I could keep making a decimal, but I'm just going to say 1/4. So again, we want this to be a whole number. So this is between 131 and 132. 1/4 is closer to 0 than 1, so we will round down. So our answer for this will be 131 would be what we predict. Based on the information in the table, what is the most reasonable prediction of the future number of votes for video games in the next 80 votes? So video games, only we don't want 350 students now. We're just talking about just the next 80 votes. So we will do the same thing. We'll do 15 out of 40 like the video games. So we'll assume that that same probability is going to happen for the 80, so we just multiply those. And 40 and 80 can both be divided by 40. 40 divided by 40 is 1. 80 divided by 40 is 2. Numerator is a 1, so I don't need to write it. I'm sorry, denominator is a 1. I don't need to write it at all. So 15 times 2 is 30, and that will be our end answer. Okay, number 7. When you send a mail via the post office, you have an 80% chance that it is delivered to the correct location. So 20% of the time it might be you're getting a piece of mail from somebody who moved, or they might have put it in your neighbor's box instead of yours, or something like that, okay? So 80% chance. Now let's remember there are 2 dots and a percentage sign. That's going to help remind us that we move the decimal over 2 places to the left. So this goes to the left so that we can get the probability. And when we do math without a calculator, we're going to use the decimal and not the percentage. So this will turn into 0.8, and it would be 0.80, but I don't need the 0 on the end, so I'm just going to drop that off, okay? If 430 letters are delivered on Monday, then what is a reasonable prediction for the number of letters that are delivered to the incorrect location? Oh, this word is really important. So 80% go to the correct location out of 100. That means 20% or 0.2 go to the incorrect location. And since they're asking for incorrect location, we want to use this number and not this number. So we're going to do 430 times 0.2. Now this is the same thing. This we multiplied by a fraction, which of course could have been turned into a percent. So we're just multiplying the probability by how many we have. I've just switched the order. This time it was the probability in the front compared to how many is our whole number that we're looking at. Okay, so I'm going to go ahead and just do that on the side. So 430 times 0.2. So I pretend my decimal point's not there at the moment. 2 times 0 is 0, 2 times 3 is 6, and 2 times 4 is 8. This has 0 numbers past the decimal point. This has 1 number past the decimal point. When I add that up, it's 1. That means 1 number needs to be past my decimal point, and that will be the 0. So that brings it to 86. We would expect to go to the incorrect location. On Tuesday, it is reported that 500 letters were delivered to the correct location. Based on this information, how many letters were delivered on Tuesday? So we want to know the total number of letters delivered on Tuesday. So let's think about this. We have 500 letters that were delivered to the correct location, plus whatever's going to the incorrect location will give us how many letters there were in all. The problem here is we have two blanks. We don't want to have two blanks, do we? So I have to think of this a different way. I'm going to say, okay, we know that we have a whole bunch of letters that were delivered, so that's our X. And I know that 500 of them went to the correct location. So if I multiply this by 0.8, so 80% of this whole number will equal how many went to the correct location. And this was delivered. Okay, and so now we only have one variable, and that is the total number of letters that were mailed out. So I want X to be by itself. I'm going to do the opposite of multiplying it by 0.8, and that means I will divide it by 0.8. What I do to one side of an equation, I have to do to the other side of the equation. So 0.8 divided by 0.8 is 1, so that leaves us with 1x, and the 1 is just implied out front. And I'm going to divide this, I'll do that right over here, 500 divided by 0.8. You can't really divide by a decimal, so what we do is multiply it by 10, which moves it over one spot. If I multiply this number by 10, I have to multiply this number by 10. Remember, that's equality, so that's a multiplication property of equality. So the decimal point is here. I'm going to move it over one spot, and I'll move it to right here. So I will now bring my decimal point up, and I don't have to worry about it anymore. So 8 goes into 50 6 times. That will be 48. Subtract those, and we have 2. Drop down a 0. 8 goes into 20 2 times, and that is 16. That leaves us with a 4. Drop down the last 0, and that's 8 goes into 40, and that's exactly 5 times. And we will have 0 remainder. So it looks like this equals 625. So that is what we think. That is how many letters then were delivered on Tuesday altogether. Okay? I'm going to move on to the homework in the next video. So if you are feeling pretty comfortable, what I would like you to do is, before going on to the next video, work out your homework problems, or at least work out 1 or 2. Turn on the video, check your work, then pause the video, and continue to try to use that method of pausing and then checking, because that means you're really working more independently, okay? See you on the next video.